Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002 and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about normalization and functional dependency, which are important concepts in the design and of the relational database. The objective is, first I am going to explain the concept of normalization, and then we are going to talk about the concept of functional dependency with some examples. So, first let us take up the concept of normalization. Database normalization can be explained in a number of ways, but we will look at certain perspectives of how database normalization can be explained. So, it is the process of removing redundant data from your tables or relations to improve storage efficiency, data integrity as well as scalability. In the relational model, so there are different models of databases, as you remember. We are here only talking about relational models. There are methods on how to quantify the efficiency of a database, how efficient a database is. So, the efficiency of a database depends upon the procedures that you use for determining normalization. So, the different classifications of how efficient a database are called as normal forms, in short called of NF, and there are algorithms available for converting a database between the different normal forms. So, you can have a first normal form, second normal form and so on, and you have algorithms for converting from one normal form to another normal form. Here I have not explained what a normal form is, we will go into that slowly. What is the meaning of normalization? Now, normalization basically involves splitting the existing tables into multiple tables and sometimes rejoining them or linking them when a query is asked. So, sometimes though my relational design or relation is for a single entity, we have used all the guidelines discussed in the previous lecture for designing the relational database and the schemas, and then I find that in order to satisfy a normal form, I have to split the tables. So, if I split the table, what will happen? They must be rejoined or linked together each time a query is asked. So, again normalization is the process of restructuring the logical data model of a database to eliminate redundancy. So, we have done this elimination of redundancy in a small way even when we are designing the database, but even further than that we do some operations to convert it such that it satisfies some of these measures of efficiency. So, to eliminate redundancy, organization of data efficiently, to reduce repeating data, and to reduce the repeating data is different from redundant data, I will explain that as we go along. Of course, we want to reduce the potential for anomalies during the data operations like insertion, deletion and modifications. So, this has to do with redundancy, which we already saw in the previous lecture. So, data normalization also may improve data consistency, this is a side effect, and simplify further extension of the logical data model. Suppose you want to add attributes, you want to do something, that also can, it may be simplified if you do this normalization process. So, the formal classification used for describing a relational database level of normalization is called the normal form. We discussed what is normal form before. It is a formal classification that is used to define the level of normalization. So, normal forms are normally abbreviated as NF. So, normalization again is a formalized procedure for eliminating redundancy from data by the progressive use, now I am slowly modifying the definition, by the progressive use of non-lossy decomposition. So, decomposition means splitting tables, it can be splitting records or tables without losing information. We should not lose information. If you do the splitting without losing information, then it is called as non-lossy decomposition. So, in reducing the data model to the state where each bit of information is the only one held in place, the update process is much simpler, more efficient, and inconsistencies in the database is impossible. So, what we are doing through the process of normalization is we are ensuring that the information is held as far as possible only in one place, and if you do that, what that actually means is the update process is much simpler and more efficient, because you have to do it only in one place, and more importantly, inconsistencies in the database will not creep in, because if you do sometimes if you have information stored in multiple places, what will happen? You may do the updation in one place and forget to do the updation in the other place. Then what happens? There will be inconsistency. That is to be avoided as far as possible, at all costs, in fact. So, normalization is based on the idea that an attribute may depend on another attribute in some way. So, if you take a relation, it is to do with an entity. Now, if you take such an entity, the attributes that you associate with the entity will depend on each other in some way or the other. It is most natural that it should be so. Depending on this, there are two different kinds of dependencies. These dependencies go up to the fifth normal form. We will come into the normal forms, we have not discussed that. So, there are two types of dependency: functional dependency and multi-valued dependency. So, the fundamental one is the functional dependency. Normal forms can be based on primary keys, can be based on the functional dependency, can be based on different things. So, we are going to look at normal forms based on primary keys first. So, normalization of data is a process during which unsatisfactory relation schemas are decomposed. So, now what we are trying to do, we are taking a relational schema and we are decomposing it or breaking up their attributes into smaller relation schemas, and which will hopefully possess the desirable properties. So, if you have a relation with say 10 attributes belonging to the same entity, you can choose to keep it in the same relation schema, but we find that that schema has some unsatisfactory properties. Then we can decompose the attributes, say 5 and 5, but then do not do it randomly, just do not say this first 5 and last 5, but you do it in such a way that the smaller schemas will have the necessary properties. So, one objective of the normalization is to ensure that update anomalies, remember update anomalies are 3 types: modification, insertion and deletion. This should not occur, at least the least that you want to ensure is these type of anomalies do not occur. But at the same time, we are not saying that normal forms will ensure very good database design, that is not the issue, but if it has these properties, it is likely to be a good design. 2 properties must be preserved in the process of normalization. Even when we said about database design and the formal guidelines, especially in the 4th guideline about spurious tuples, we said that some properties has to be preserved, and this is here we are going to talk about 2 types, that is the lossless join property and the dependency preservation property. These 2 have to be preserved. So, prime attribute is a member of any of the key and non-prime attribute is not a prime attribute. So, these are 2 definitions we are talking about before we go into normal forms. We are not going to talk about normal forms in this lecture, we are only going to talk about normalization and the fundamental aspect of these normal forms, the functional dependency. So, as I already told you, there are different types of normal forms, and actually progressively it is more stringent in constraints. So, you have first normal form and then you have second normal form. Second normal form is first normal form plus something, then you have third normal form which is second normal form plus something, and so on. So, that is how it progressively increases. So, you have 1NF is based basically on primary keys, 2NF, 3NF and BCNF, BC is Boyce-Codd normal form, is based on keys and functional dependencies. 4th normal form is based on multi-value dependencies, the so called MVDs, and the 5th normal form is based on keys and joint dependencies, okay, or JDs. But in addition to all these properties, you may need other properties to ensure good database design. So, let us just go first normal form based on keys, second normal form, third normal form BCNF based on keys and functional dependencies, 4th normal form based on multi-value dependencies, and 5th normal form based on joint dependencies. So, these are the basis of normal forms. In fact, given a relational design or a schema design, you can keep on progressively applying these normal forms, but 4th and 5th are not so generally used. If you go up to BCNF, it is fine. As I already told, it is a subsumption, that is 2 assumes 1 is there, 3 assumes 2 and so on. So, what are the practical use of these normal forms? I have not told you exactly what are the different normal forms. So, normalization is carried out in practice so that the resulting designs are high quality and meet the desirable properties, and the practical utility of these normal forms will become questionable when the constraint on which they are based are hard to understand or detect. So, this is one negative so to say of normal forms, because the normal while you are doing this normalization process, you keep splitting the tables and so on, such that the design that is finally left behind after this normalization process may not be very easy to understand, and the database designers need not normalize to the highest possible normal form, usually up to 3NF, BCNF, certain database designs up to 4NF, you never try 5NF. De-normalization also we will define that concept of de-normalization. This is the process of storing the join of higher normal form relation as a base relation, which is a lower normal form. This is also called as denormalization. So, let us go to the next concept, which is functional dependency. Now, before we go to functional dependency, again let me tell you what is normalization. So, normalization is a property, is actually defining how efficient my database design is. Okay, that is the basic concept of normalization. And because of normalization, what will happen? Redundancy will be reduced, you will have a better more efficient design, and you will not have any of the update anomalies. Okay. Now, normalization is again dependent on two properties, functional dependency and multi-valued dependency, also joint dependency. So, these are the two things, and the keys, primary key and non-primary keys. So, primary key, non-primary key, functional dependency, multi-valued dependency, and only for fifth normal form it is joint dependency. So, the normalization process is conceptually based on these things. Okay. Then we have the different types of normalization. We have first normalization, which is based on keys, second normalization, third normalization, and BCNF comes in the middle. These three based on keys and functional dependency, fourth normal form on multi-valued dependency, and fifth normal form on joint dependency. Then we looked at the uses of this. Now, let us look at the fundamental concept of normalization, which is based on is functional dependency. So, here we are going to explain the concept of functional dependency, and we are going to look at the need for functional dependency. So, functional dependencies are used to specify formal measures of the goodness of a relational design. Okay. And keys are used to define normal forms for relations, and constraints that are derived from the meaning and interrelationships of the data attributes. So, functional dependencies are these. Okay. So, you have normal forms. So, basically functional dependency are used to define the normal forms. So, what is this functional dependency? Let us answer that question first. A set of attributes x is functionally determines a set of attributes y if the value of x determines a unique value for y. Now, let us again look at this. Let us take a set of attributes x. A set of attributes x, for example, employee name, employee number, is functionally dependent on a set of attributes y, another set of attributes y, if the employee number decides the employee name, and the employee number or the employee name determines the employee address, not necessary, determines the employee, what do you say, characteristics or something like that uniquely. So, if for one employee number you will have only one name. So, that is a unique dependency, that is called a functional dependency. So, x y or x functionally dependent on y holds if whenever two tuples have the same value for x, they must have the same value for y, that is the meaning. So, if x is so employee number, for example, one employee number will have only one name. So, if you give another value, you cannot have two names for the same employee number. Primary key is very straightforward, but for non-primary keys also functional dependency holds. So, for any two tuples T1 and T2 in any relation, if T1x is equal to T2x, then T1y is equal to T2y, that is the meaning of functional dependency. We will go in further into detail about functional dependency as we proceed. Now, let us take a small break. Come back after the break. Now, before the break we were talking about normalization and functional dependency, and we said that we will talk about functional dependency in detail, because many of the normal forms, as we already saw, second normal form, third normal form, BCNF, all these three normal forms are based on keys and this concept of functional dependency which we have told. Now, what is functional dependency? It says that if you have two tuples, remember tuples are records, and for one attribute you have one value, okay, and for the other attribute you have another value. If you get the same attribute again, same value again for that attribute, you can have only the same value for the other attribute. I will explain this again. I gave an example with employee number and employee name. Let us not take that. Let us assume that in a company an employee can work only in one department, let us assume like that. Then you have employee name functionally decides the department. Okay. So, employee name department, if that same employee comes again anywhere, he will be associated only with the same department. This is only when the constraint is that one employee can work in only one department. But the other way it is not true. Why employee department gives rise to employee is not true, because in a one department name you can have employee, say for example John, and you can have the same department you can have another employee Henry. So, y is not dependent on y does not give rise to x, but x gives rise to y. So, this is what this is explaining. So, x functionally decides y holds if whenever two tuples have the same value for x, they must have the same value for y. So, if you have two tuples T1 and T2, two tuples are two records in a relation. If two tuples have the same x value, then it is necessary that the two tuples should have the same y value. So, x functionally dependent y in R specifies a constraint on all relation instances. FTs are where do you get these FTs? FTs are derived from the real world constraints on the attributes. Example that I told you, employee number, employee name, okay, that is a constraint. That is actually a entity constraint, but I gave you a application constraint where I said that one employee is allowed to work only in one department, then that is an application constraint that can also give rise to a functional dependency. The first functional dependency of employee number and employee name is due, the functional dependency is valid because of the fact that employee number is a primary key, but in the second case it is not so. Okay. I can have employee name and it is not a function primary key, but employee name he will work only in one department. Okay. So, that is the functional dependency. This is a two relational schema suffering from update anomalies. We have seen this example where employee project and employee department. Now, let us look here. If you look at this, this is the SSN number primary key. Primary key decides a employee name, okay, and the birth date, address, department number, department name and manager. Here you have three functional dependencies. The SSN, that is the employee social security number, determines the project number and the number of hours he works. So, number of hours is unique for each employee, and the project number he works for, assuming he works for only one project, is unique. Or if you take these two together, this is determined by SSN. SSN cannot work on the same project for different number of hours, okay, in the same time obviously. Then you have here the SSN and the E name, this I have already explained, and then you have P number and P name. So, if the P number is 1, it can have a project name, the same P number 1 cannot have another project name. Okay. So, this is similar to the SSN E name, P number and P name. So, this is the functional dependency. So, social security number determines the employee name, which we have already seen. Project number determines the project name and location. So, project name, because the same project number in the project number you can have project name and the project location is determined. Similarly, employee and the project number determines the number of hours, both together. So, look at the difference here. Here one attribute decides another attribute, functionally dependent. Here one attribute determines two attributes, because you can have another project number, the same project name, but different location, or you can have the one project number, same location, but different project names. So, that is allowed. So, this is a different interpretation of what that attribute means. And the third case where employee SSN and project number, those here you have two attributes together deciding hours. Now, this employee can work for different hours on different projects, and so, but on the same project he can work only the same number of hours. Of course, it is assuming that is the same duration. Okay. So, this is an example. An FD is a property of the attributes in the schema R, and the constraint must hold good on every relation instance. For every tuple this must be true. It is not a relation, it is about tuples in the associated with the attribute values. If K is a key of R, then K functionally determines all attributes in R. So, if it is a key, since we never have two distinct tuples with T1k equal to T2k, this is implied automatically. If it is a primary key, There is no question of two tuples having the same value for that primary attribute. So, essentially it means that there can be only one value, for example, SSN number. SSN number you will have 1, 2, 3, 1, 2, 3 can come only in one tuple in the whole relation because of the property of the primary key. Okay. Now, since that is so, it can have only one value. So, functional dependency is automatically implied in the case of primary key. So, that is why I said SSN number and E name, employee name, or project number and project name, all those are primary key attributes. So, so that is automatically functionally dependent. So, this functional dependency is a framework for systematic design and optimization of relational schemas, and it is a generalization over the notion of keys. Okay. It is actually little more than keys, and it is crucial in obtaining the normalized schemas. For example, in the first normal form, we will come into these normal forms only later. In the first normal form, okay, you look at only the primary key. In the second normal form, you are looking at the functional dependency. The functional dependency decides on how to split the schemas. Basically, we are going to split the relation into two. So, there we are going to look at the functional dependency in order to do this. So, basically the functional dependency is a little more information about the relationship or interdependencies between the attributes without looking at other things. Functional dependency for any two tuples, which we have already discussed, T1 and T2, such that if T1x equal to T2x, we must have T1y equal to T2y. I will just explain this in detail with an example. So, this is tuple 1, this is the attribute x. So, let us say project, we took that example. In a tuple, if the project number is 5, okay, and in another tuple the project number is also 5, okay, both you have 5, then y, in our case y was p name and p location, both together, that is the tuple corresponding to p. So, let us assume budgeting, or let us say billing and location, say let us say Chennai. So, billing Chennai. So, here you have project number 5, billing Chennai, and if in another tuple you have 5, then this has to be again project Chennai, it cannot be anything else. I am sorry, billing Chennai, it cannot be anything else. Of course, because it has two attributes, you can have 5 here and you can have billing Chennai, you can have 5 here and you can have billing Mumbai, that is allowed, but both together cannot happen, it has to be equal. So, if this functionally dependency holds good in R, it does not say anything about y going to x. So, let us go again and take this. If the p name and the p location are same, it does not necessarily mean that the p number should be the same, and if hours are same, it does not, this makes more sense, you can understand the constraint. If say 15 hours, 15 hours, it does not mean that 15 hours can be worked with by only one employee SSN for one project. It can be different SSN, different projects and so on. So, this functional dependency does not hold good. So, a functional dependency cannot be inferred automatically from a given relation, but must be defined explicitly by someone who knows the semantics of the attributes. So, this functional dependency has to be explained or given explicitly by a person who understands the application and understands the properties of the attributes that he has used in the design of the relational database. So, example, let us take an example database of teach. So, here you have teacher, here you have course and here you have text. Now, study this property. You have the same teacher teaching two different subjects and using two different textbooks, and you have the same course taught by two different teachers using two different textbook, anything else, that is it. So, these are the two repeats that you see. Now, the teach relation state with an apparent functional dependency text equal to course. So, in this particular example, it looks as though text determines course. So, if you have a text, this bar term can write data structure. So, if bar term comes again, it has to be data structure. What that is imply as far as an application is concerned, bar term cannot write any other subject textbook, that is what is implied, but from this example it looks like that. Okay. So, this is an apparent functional dependency. Okay. But for a course you can use different text. So, from this example this functional dependency, course to text does not exist, but text to course exists. Whether it is correct or not is a different issue, it depends on the application, how you understand the attributes of the application. But in this example with these tuple values, it is valid. Text equal to course, I mean text to course is valid. Now, let us take another example. Here you have supplier number, here you have city, and here you have the product number, and here you have the quantity. So, here supplier number and the product number, quantity is fixed. So, these two are these two. So, if you have S1 P1 again, you do not have S1 P1 again. Let us take S4, S4 P2, S4 P4, S4 P5. Okay. For P2 you can't have the, so because 2 comes here, S1 P2 you can have, then with P2 you should not have S1 anywhere else, it is not coming. Similarly, with S1 you can have P2, with S1 you cannot again have something else, I mean with the S1 P1 S1 P2 combination you cannot have something else. So, this says these two together functionally determines quantity. So, quantity is functionally dependent on S number and P number. So, are determinant of quantity. So, a relation including attribute A and B, B is functionally dependent on A if for every valid occurrence the value of A determines the value of B. That is another explanation of what you mean by functionally dependent. Now, occurrence cannot be used to show that a dependency is true, only that it is false. So, because it depends on the number of tuples you have put in the database. A and B can be composite, that we have seen examples where A can be composite or B can be composite, either side of the functional dependency. B is functionally dependent on A, then A is the determinant of B, that is the terminology used. All fields are functionally dependent on the primary key or indeed any candidate key by definition. By definition itself this is true. So, primary key relating, for example, we had SSN, so that is considered. Now, let us consider the following relational table supply. Table describes suppliers of computer parts and parts ordered, suppliers specified by supplier number. We maintain information about the supplier and the city. So, the attributes are supplier number, product number, city, quantity, status. Each tuple uniquely determined by the combination of supplier and product together. So, supplier and product together is the composite key. Once supplier number is known, the city where supply is located is uniquely determined. So, you have supplier city functional dependence. Status of the order depends only on the city where the supply is located. In other words, 2 orders from the same supplier will have the same city and 2 orders from the same city would have the same status. So, example, here we have an example of that same relation, and this is not allowed in the table. Now, you have here 101 and A1, that is supplier number, part number. We say that determines the quantity. So, with 101 A1 you cannot have some other quantity. So, that is what is it violates that dependency. The pair supplier part number uniquely determines the tuple. There cannot be 2 different tuples with the same values of supplier and part. So, that is so these 2 determines all the 3, because these 2 together is the primary key or the candidate key. So, similarly, this is not allowed because the city is determined by the supplier, that is what we have defined. Since supplier 101 is situated in London, according to the situated in London, you cannot have another Paris associated with that. Okay. The following tuple is also not allowed because the status is determined by the city and London already has a status of 20. So, giving it another status is not allowed. Okay. So, the following tuples are not allowed of the status. So, the following tuples are allowed. So, you can have different supplier numbers and all that is allowed. So, what is observed from this? Values of a set of attributes uniquely determines the values of the other set of attributes, and some set of attributes uniquely determine the tuples values of all other attributes. So, that is if it is the candidate key. So, a set of attributes supplier uniquely determines the value of the attribute city, a set of attributes city uniquely determines the value of the attribute status. So, this is these 3 are because of the key, and this is because of the functional dependency, and this is again depending on the functional dependency. So, this 2 together determines all the 3, this alone determines city, this alone determines status. So, we have explained the concept of normalization, and we have explained the concept of functional dependency with some examples and why we need the concept of functional dependency. Do the following exercise. Define what is normalization. We have given different aspects, so explain it. Define the term functional dependency, and then using an example, again you can take a student and a registration fees example and explain the characteristics of what is meant by functional dependency between attributes, how it is defined.